now say this is not only an alien spaceship, but it's nuclear powered? Why are you saying that?
First, I should say that if the light that we observe from this object is reflection of sunlight, its size needs to be bigger than Manhattan Island. In this case, what we are seeing is a glow in front of the object. And I'm analyzing first if this is caused by dust. The amount of dust is very little. Over 6 months, the amount of dust that will be ablated from...
September 12th, 2025. A day the sky flipped the script. Astronomers were locked in on their screens when something wild ripped in from deep space. A gigantic object slicing across the darkness with a tail so huge it stretched 5 times wider than the full moon. This thing made every other cosmic visitor look tiny. Even the famous Oumuamua couldn't compare. And before experts could finish arguing over what they were seeing, boom, a second mystery object got picked up, coming in hot from the opposite side of the sky like it was perfectly timed. The chance of 2 massive space outsiders showing up weeks apart, but from totally different directions. Experts said the odds were astronomical, and that's when people started whispering that the official explanation, just twin comets, wasn't adding up. Something about this felt way too precise, too clean, too planned. Like someone, or something, sent these objects with purpose. A bigger, unknown visitor drifting into our solar system, moving like it had a mission nobody on Earth could explain. So what's really going on here? A freak interstellar coincidence, or the opening move in some operation we weren't supposed to notice? Whatever the truth is, it all kicked off the moment SOHO's SWAN instrument caught that first object blazing through the solar system like it owned the place. The early data hit fast. That tail wasn't just long, it stretched nearly 2.5 degrees across the sky. That's huge, 5 full moons wide, impossible for a fresh discovery. Photometry read it at magnitude 7.4, bright enough for anyone with a little backyard setup to spot it. And once the news leaked, amateur astronomers jumped into action, aiming their telescopes like they were chasing a ghost nobody expected to show up. Just 2 days after the alert, an observer in Australia snapped an image that had people losing their minds. A blazing streak so stretched out, it nearly burst out of the camera frame. The kind of shot that makes you wonder if this was really a comet, or something way more intentional. By September 13th, the International Astronomical Union made it official. The cosmic intruder got stamped with the name C/2025 R2 SWAN, honoring the instrument that snitched on it first. And once that name dropped, the whole sky-watching world went into overdrive. Professionals, amateurs, night owls with backyard scopes, everybody locked in on this monster, trading images and brightness readings like it was the hottest secret in the universe. The size and brightness had folks' jaws on the floor. Modern comets usually sneak in dim and dusty, needing big telescopes just to prove they exist. But SWAN? This thing showed up shining like it wanted attention. Anyone who knew the spot could catch it slicing through Virgo like a glowing blade, getting brighter every single hour as it pushed closer to the sun. It felt too bold, too staged, too dramatic to be some regular icy rock drifting around. People weren't just excited, they were straight up stunned. The data did not line up with anything seen in recent memory. This wasn't some chill interstellar visitor passing through. SWAN was operating on another level, dominating the inner solar system like it was stepping into a spotlight. And the amateur community, always first to spot weird behavior, was already arguing about what kind of force could build a tail that long and that bright. The debates were wild, and the theories kept coming. One thing was dead clear: SWAN was too big, too loud, and moving way too fast to ignore. And as telescopes worldwide traced its path, the real question switched from, "What is this thing?" to, "Why did it show up now?" Its timing felt sharp, suspicious even, like it was part of something bigger. Maybe a cosmic message, maybe a warning, maybe a plan we weren't meant to see yet. And just when astronomers thought it couldn't get stranger, boom, SWAN wasn't even alone. Another object named 3I/ATLAS had already been spotted days before, sliding in from a totally different slice of the sky. Swan's trail leads back through Aquarius, while Atlas came roaring in from Sagittarius, two directions separated by more than a quarter of the whole celestial dome. Yet somehow, both of these outsiders are set to hit perihelion, their closest point to the Sun, within the same 10-day stretch. Two massive objects, different origins, same deadline. Something about that feels way too coordinated. That key moment hits around October 20th, when Swan swings past the Sun at about 150 million kilometers, a tight cosmic drive-by that had astronomers sweating. And Atlas. It pulls up just 3 days earlier on October 17th, gliding past at roughly 203 million kilometers. That puts their closest approach spots only around 50 million kilometers apart, closer than Mars ever comes to Earth. That kind of alignment isn't random. It's too sharp, too clean, too exact. This isn't just about dates lining up. The geometry is straight up wild. Both objects are riding steep, tilted orbits, Swan flying more than 60 degrees off the ecliptic, and Atlas coming in almost sideways, nearly perpendicular to the planet's path. Their approach angles are so different, the odds of them dropping into the inner solar system at the same time and at almost the same solar distance are basically zero. Astronomers who study long-period comets and interstellar objects are used to pure chaos, random arrivals, scattered perihelions months or years apart. But this is two of the brightest newcomers of the decade showing up like they coordinated the meetup. And the timing makes it even stranger. As both Swan and Atlas hit their closest point to the Sun, Earth's telescopes get knocked out from October 8th to 18th. The Sun's glare wipes out direct viewing, creating a blackout window right when anything unusual would be happening. That means their most critical moments, their closest pass to the Sun and to each other, unfold just barely out of reach, with ground observers forced to watch blind while the action goes down behind the solar curtain. For two objects coming from wildly separated origins to strike perihelion within days, at almost identical distances, and during a period when the Sun conveniently hides them from Earth's eyes, that goes way beyond coincidence. In orbital dynamics terms, this is a corridor, a tight little slot in space and time both objects somehow slide into together. And whether that's pure chance, some hidden connection, or something engineered on purpose, nobody can say yet. But the geometry alone is enough to make even the biggest skeptics hit pause. And Atlas? That object didn't grab attention just by showing up. It did it by breaking rules. Early spectrograph readings from the Atlas Spec Lab crew sent a chill through the community. They found something that shouldn't exist on any comet, a body loaded with nickel and showing almost no iron at all. That flips the entire playbook on its head, because comets usually vent iron-nickel blends when they heat up. But this one? It wasn't following any known script. It looked less like a natural wanderer and more like something crafted from a different blueprint entirely. The claim shook the astronomy world so hard that labs started calling for an immediate recheck. The readings were so wild that people thought the instruments had to be glitching, and the drama spilled onto forums where experts argued non-stop. Independent teams jumped in trying to settle the mess, but the next round of data made everything even louder. Instead of showing the normal water vapor signature, 3I/ATLAS was blasting out carbon dioxide, and not just a little. It was pumping CO2 at 5 times the rate of water, with the 4.3 micron line overpowering every spectrum like it owned the place. H2O barely peeked out of the noise. That's rare but still possible for deep, cold comets. But the rest of the behavior? Way harder to explain. Observers following Atlas started noticing something that didn't look natural at all. 3 separate bursts of acceleration, each hitting around 2 weeks apart, and each one flipping the tail's color like someone was switching a setting. The first hit on July 29th, the second on August 14th, and every time the brightness jumped hard while the spectral slope slid from reddish to almost neutral before sliding back again. These weren't smooth moves like what you get from sunlight heating a comet. They were sharp, fast pulses, fading just as quickly, almost like the object fired off a controlled push. Peer reviewers pushed back heavy, warning that the readings could be calibration drift or hidden technical errors. But the Atlas Spec Lab squad doubled down, saying the pulses matched up across completely independent systems, from the Aber-O Tracker network to Bill Gray's Distributed Telescope Array. When different observatories see the same thing at the same time, it becomes real hard to brush off. And the numbers weren't acting like normal outgassing at all. The CO2 mix in the tail kept shifting in perfect sync with each jump in speed, something a few researchers started calling thrust mix modulation. That phrase alone had half the community raising eyebrows because it hinted at something acting more like a machine than a chunk of frozen rock. Then things really kicked up when the energy estimate leaked. If those accelerations were legit, Atlas would need a power source hitting around 10 gigawatts, the output of 10 huge nuclear plants. No known comet nucleus could even dream of producing that kind of juice. Even the mainstream crowd, the ones insisting everything must be natural, had trouble explaining how an object could pull off moves like that while also throwing off a nickel-only spectrum that doesn't match any known classification. So now the debate stays alive, hotter than ever. The official stance says natural processes can still explain most of the readings, but the holes in the data, the nickel signature, the step-like accelerations, the synchronized CO2 behavior, keep the engineered object theory on the table. The ATLAS anomaly file stays open, and every new data drop has people choosing sides fast, fueling skeptics and believers alike. C/2025 R2, now just called SWAN, sits in its own lane, towering over everything else in the sky. The numbers hit hard, a tail stretching 2.5 degrees across the heavens, brightness levels competing with the greatest comets of the past 100 years, and energy output estimates so wild they sound unreal. Some projections put SWAN pushing out nearly 10,000 gigawatts, more power than the entire electrical grid of Earth combined. That's not just big, that's outrageous. But what's really turning heads isn't just the size or the shine. It's the claims sliding in from the edge of the astronomy world. People whispering that SWAN isn't just a natural object. It might be armored, shielded, and powered by tech that blows past everything humans know. The first sparks of these rumors came from the reflectance data, because comet cores are supposed to scatter sunlight in smooth, predictable ways. But SWAN's core hits back with a metallic signature that made researchers freeze. A few amateur spectroscopists swear the readings match a nickel-cobalt blend, the same materials used on Earth when you want something tough, corrosion-resistant, and built to last. Soon the phrase nickel-cobalt hull started bouncing around late-night podcasts and chat rooms, especially as SWAN refused to crumble, dim, or behave like anything the sun usually destroys at close range. Then things got even weirder. Reports came in about an optical anomaly, a smooth, silvery halo hugging the nucleus, shifting in patterns that didn't match dust or gas. Some thought it looked like a plasma envelope, basically an electromagnetic shield protecting the core from solar wind and space debris. That's when SWAN picked up the nickname the Fortress. And compared to 3I/ATLAS, which moves like a fast drone with sharp efficiency, SWAN feels like a heavyweight tank, slow, unshakable, and rolling forward like nothing can touch it. Its monster tail, already breaking records, shows micro-thrust pulses that scientists can't pin on normal outgassing. Photometric studies reveal tiny rhythmic shifts in the tail's direction, like the object is making clean, precise course tweaks with controlled plasma bursts. Each move pops up as a spike on the brightness curve, and the weird pattern repeats just enough to look intentional, nothing like random surface eruptions. And then there's the orbit. Swan is running a cycle of 22,554 years, a period stretching back to the era of ice sheets and ancient megafauna. If this thing were engineered, that means someone or something set its route long before human civilization even existed. And yet, here it is, showing up now, in perfect sync with Atlas, sliding into the exact same solar corridor during the one window where Earth's telescopes are basically blind because of the sun's glare. The timing is so sharp it feels less like coincidence and more like a planned arrival, a cosmic meetup we were never supposed to catch. The odds of all these pieces lining up by pure luck are basically non-existent. Everything stacked together makes Swan feel way bigger than some random comet drifting through space. Its insane luminosity, the whispers about advanced shielding, the possible armored hull, and that ridiculous energy output make it the most intimidating object to roll into the inner solar system in anyone's lifetime. Whether this thing is a fortress, a probe, or something we don't even have a name for yet, SWAN has pushed astronomers into rewriting their own rules and entertaining theories that used to live only in sci-fi stories. Every strange detail logged for SWAN and 3I/ATLAS has shifted the whole conversation. People aren't asking what these things are anymore. They're asking what they're doing. When two massive bodies, one on a 22,554-year return cycle and the other flying a hyperbolic, maybe interstellar path, show up almost together, the chance of coincidence drops to nothing. The timing, the bizarre geometry, and the observation blackout window have turbocharged all kinds of mission theories. One idea actually sounds almost normal by cosmic standards: a scheduled maintenance or refueling stop. In that version, the sun becomes a pit stop. Both objects could be engineered to recharge using solar energy or magnetic fields, swap data, or run a full systems check. And honestly, that tracks with how Earth handles deep space missions. Solar flybys are routine for gravitational assists and energy boosts. If these objects are probes, hitting the sun for a tune-up would make sense. But another theory isn't so friendly. Some people think this could be an intervention, a pull-up moment to neutralize a malfunctioning unit, recover something drifting off course, or even a standoff between rival factions meeting at a shared resource. And those estimated power levels? Atlas clocking around 10 gigawatts and Swan hitting a mind-blowing 10,000. That's the kind of energy you'd need for serious maneuvering, not lazy drifting. The step-like accelerations in Atlas and the micro-thrust pulses in Swan look a lot more like controlled moves than random bursts of outgassing. Then there's the audit chain scenario, starting with Oumuamua in 2017, then Atlas, and now Swan. Some think these could be escalating checks triggered by Earth's last century of radio transmissions, each arrival more advanced than the one before it, a chain of probes coming to verify, gather data, or ramp up whatever comes next. In all these possibilities, the sun isn't just background scenery. It's the meeting point, the power source, or the checkpoint that ties the whole operation together. It's the power node, the meetup spot, the beacon that everything seems to circle around. None of this evidence settles the argument for good, but it forces a new, heavier question. If this really is a mission, then what's the mission? A 22,554-year orbit isn't just a number thrown on a chart. It's a cycle that reaches all the way back into the last ice age, a time when the planet looked nothing like today. Around 20,000 BCE, glaciers smothered huge chunks of the northern hemisphere, and the climate was bending in ways that shaped humanity's earliest moves. That same era left fingerprints in the ice cores of Greenland and Antarctica, layers of dust, weird chemical shifts, tiny clues hinting at sudden dramatic events lighting up the sky. Some researchers point out that these layers sync up with moments when bright, long-period comets might have swept past Earth, leaving not just debris behind, but stories. Stories that could have been passed down so long they turned into myths. At the center of this idea sits Göbekli Tepe, a site in southeastern Turkey built more than 11,000 years ago. Its massive stone pillars carry carvings of animals, symbols, and patterns that have confused experts for decades. But some theorists claim those symbols aren't random. They say certain carvings map the sky, show celestial paths, maybe even track comets. A few go further, arguing these carvings' record cycles far longer than a single lifetime, possibly marking the return of something like SWAN. The mainstream crowd stays cautious, though. Archaeologists and astronomers warn that these connections might just be people drawing lines where none exist. They say the patterns could easily be coincidence, and the debate gets heated fast. Critics keep reminding everyone that no direct proof links ancient monuments to specific orbital cycles, and that guessing too hard can twist history into fantasy. But still, the timing refused to sit quietly. If SWAN really does swing back every 22,554 years, then its last visit would have happened right as the glaciers were fading and humanity was stepping into a new chapter. People were beginning to build structures, track the sky, and create symbols meant to outlast generations. Whether that's pure chance or something deeper is still wide open. But the overlap hits with a strange, mythic weight. In the end, SWAN's story isn't just about raw numbers or orbital charts. It's about the possibility that these rare sky visitors might have always been part of our own origin story. That maybe humanity has been watching, wondering, and trying to understand cosmic arrivals like this since the very beginning. From October 8th to 18th, every major ground-based observatory hits a brutal halt. The official paperwork calls it solar conjunction downtime, but behind the scenes, the rules get way tighter than anyone expected. Internal memos from US Space Command and the European Space Agency straight up order teams to freeze all radar scans and high-resolution imaging of both SWAN and 3I/Atlas. No exceptions, no workarounds, nothing. And once that blackout kicks in, things start looking even stranger. Proposals for backup coverage get denied with zero explanation. Requests for raw data get rerouted, delayed, or quietly buried. A couple telescope allocation reviewers, speaking off the record, admit they were told not to say a single word about either object until after perihelion. That turned the whole event into a forced silence, right when Earth needed eyes on the sky the most. But while the big agencies went quiet, the amateur networks refused to roll over. Bill Gray, a legend in the tracking world, jumped in immediately. Known for his open-source orbit work, he started rallying a whole web of backyard astronomers and small observatories. His message spread across public forums and encrypted chats. Keep watching, log everything, don't let the data vanish. And people listened. The Ibero Tracker Collective out in Spain and Portugal began linking their wide-field sensors together, turning scattered equipment into a coordinated net. Leaks from private astronomy groups hinted at homemade plans to dodge the blackout using radio telescopes and even repurposed weather satellites. With government agencies off the record and major observatories locked down tight, the grassroots crew suddenly became the only line of defense against a total information blackout. Anyone with a telescope, a radio dish, or even basic tracking software could step in. The blackout window wasn't just a restriction, it was a dare. An invitation to jump in and be part of the hunt for the truth. Because when SWAN and ATLAS finally break out of the sun's glare, the first signals might not come from a government science hub. They might come from somebody's backyard, somebody's garage, or somebody's homemade rig aimed at the dawn sky. The facts stay solid no matter who tries to quiet them down. Two anomaly-level objects entered the inner solar system together, moved like nothing on the record books, and shattered the odds while raising questions nobody in power wants to answer. If you're still here watching this unfold, you're already part of the story. Drop a comment telling us what you think is really going on, smash that like button, subscribe to StellarDrift, share the video with your crew, and I'll catch you in the next one.